Hello everyone, my name is Taksapon Sirirat. I'm from Major University and today I would like to present on my research in the topic that is gradient projection methods for constraint convex minimization problem. And my advisor is Associate Professor Pathanapong Tianchai. In order of my present, I will present 1 abstract, 2 introduction and preliminaries, 3 main results, 4 application, 5 example of numerical results, and the last will be conclusion. First, let's start at abstract. In this paper, we introduce an iterative scheme using the gradient projection methods based on Maldavi's viscosity approximation methods for solving the constraint convex minimization problem. In this, we use CCMP, and the CCMP is to find a minimizer Q in C of function G over ZC. And this problem transformed into the space feasibility problem. In this, we use SFP. And SFP is to find Q in C such that AQ in Q, where A is a linear bounded operator on setting in the Hilbert space. And we suggest and analyze this iterative scheme under some appropriate conditions, improve on the parameters, such that another strong convergence theorem of the CCMP and the SFP are obtained. And the results presented in this paper improve and attain the main result obtained and shared in this paper and many others. Next, I will present introduction and preliminaries. In this paper, we always assume that C be a closed convex subset of a real Hilbert space H, and let G be a strictly Liouville convex function. Now, we consider the following constraint convex minimization problem, that is, minimize Gxx in C, and assume that this problem has a solution. If G is a differentiable, we have the gradient projection algorithm is usually applied to solving the constraint convex minimization, which generates a sequence xn through the recursion. That is, xn plus 1 equal the composite function of PC and I minus lambda gradient of function g of xn for all non-negative integer number of n. Or more generally, we change lambda to lambda n, where x0 in C is chosen arbitrarily. The parameter lambda or lambda n are positive real number, and PC is the metric projection from H onto C. Next, I will show the timeline of my issue. In 1966, Levitin and Poyat introduced this sequence. In case of gradient, G is a alpha strongly monotone and Lipschitzian. They proved that this sequence converges strongly to the minimizer of the constraint convex minimization problem. But if a gradient of function G is satisfied only the Lipschitzian, they proved that this sequence converges weakly. Next, 2010, so introduced this sequence. In case of gradient of function G is 1 by L inverse strongly monotone, he proved that this sequence converges weakly. And I don't know this sequence may converge strongly or not. Until 2017, Tian and Cheng introduced this sequence, and they proved that this sequence converges strongly. And now, we study this sequence where H is contraction, gradient G is 1 by L ISM, and determine some appropriate of the parameters. We obtained a strong convergence theorem to solve the CCMP. Next, we will show how to use the iteration to find a minimizer of function G. And methodology. We start x0 in C, and x1 we can do in the composite function of PC and I minus lambda gradient of function G at x0. See the picture? This is a gradient of function g at x0 is the same directional of normal vector. In Thai language, we said vector ตั้งฉาก1 หน่วย and it is minus lambda gradient of function g at x0. And we get the red vector. It is the resultant vector of x0 vector and this vector. And its projection is x1. And if we do by the same way, so we get x2. x2 is the projection of the resultant. And we get x3 and so on. And then xn convert to q of the function g. That is, the function g at q is the minimum of this function. Next, I will explain the projection from H onto C. Let C be a closed and convex subset in the Hilbert space H. Recall Z is a projection of X on C. Is the unique point in C satisfy this in equation. And what is a strictly real value convex function? Let's see together. This function is not strictly because it has many points of minimizer of g. But this function is strictly because it has the unique points of minimizer of g. And next, I will give a definition of L-Lipschitzian contraction and 1/L inverse strongly monotone. T is said to be L-Lipschitzian if T satisfies the following in equation. And if L equal 1, mapping T can reduce to the contraction. And 1/L inverse strongly monotone is also in L-Lipschitzian. And our work we study in case of gradient of function T is 1/L ISM. Now on my stage, I'm proud to present the main result. As following the statement, we studied this sequence, and we can show and prove that this sequence converges strongly to Q, which is the unique minimizer of the CCMP under condition 1, condition 2, and these parameters. And the sequence, if we put alpha n equals 0, we obtain the new sequence, which is the main result of Tien and Cheng. And we solve that the condition 3 can be removed. Next, application of my research. We now consider the space feasibility problem, which introduced in 1994 by Sensor and Irving. Define the convex function g as follows. And we well know gradient g is the composite function of a star I minus p, q, and a. And gradient g is 1 by norm a squared inverse strongly monotone. We have the consequent results as follows. And we can prove that this sequence converges strongly to the unique minimizer of the minimum norm solution of the SFP under the same condition. And this sequence, if we put alpha n equals 0, we obtain the new sequence. And we can prove that it converges strongly to Q under the same condition. Next is a numerical result. We will set this parameter same this. Example, find the solution of linear equation system as follows, where x, y, and c in R. Let h1, h2 in R3. Take a and q same this. We choose x0 in C arbitrarily. And we can reduce xn plus 1. And then we have xn converge strongly to q. And this is a numerical result of this example. You see numerical result is 1, 3, and 2. And the last conclusion. In this paper, we obtained an iterative scheme using the gradient projection method for solving the minimum norm solution of minimization problem and also solve the space feasibility problem, such that another strong convergence theorems of the CCMP and the SFP are obtained. Now we will stop to present my research. Thank you.